All right. Adding and subtracting. Let's go. So, number one, 12 over 5x plus 7 over 6x. All right, so the idea, right, is that we need a common denominator. That's going to be the theme throughout all these problems. Is a common denominator. You got to have a common denominator. So I'm going to multiply each side by whatever's in the other side's denominator. Right, so all right. So I look at the left side, meaning 5x, or however you want to look at this, right? At the end of the day, I got to multiply both sides by something. So starting with the far left, I'm going to multiply it by, so you look to see what is in the other denominator. So the other denominator has an x. The denominator on the right has an x. Okay, so I'm not multiplying by that. The other denominator has a 6. So that's what I'm going to multiply the left side by. Top and bottom, right? 6 over 6. So the far right, I look in the other denominator to the left, and it has a 5. So that's what I'm going to multiply by. So that's the idea, right? You whatever set of parentheses, am I doing the left set or the right set? Whatever set you're trying to figure out, what am I going to put in the parentheses, you have to look at the opposite denominator and just see what is in that denominator that the other denominator doesn't have. Now, this is going to come out to, so the denominator in the end is going to be 6 times 5, which is 30x. So this is going to be 30x, 30x. 6 times 12, 72, 35. All right, so then because the denominators match, they're equal. This is going to be 107. 107. Now, let's just say you don't like that. And, I get it. It's uncomfortable, right? Because you're having to like think and try to figure things out. If you don't like that, then the only other way to get to a common denominator is simply by multiplying by whatever the other denominator is. So for instance, instead of 5, you could do 5x, and then the left hand side would be 6x. That's the only other way, right? Now, multiplying by x is kind of irrelevant, right? Or not irrelevant, redundant, right? Meaning you didn't need to. I didn't need to multiply by x simply because both denominators already had x. But if you don't catch it and you don't see that, then that's fine. You could still multiply by whatever, as long as the top and bottom, the numerator and the denominator of the fraction that you're introducing does match, right? Like it's got to be whatever the denominator is, that's what the numerator has to be. So you look at the other denominator. These are the only two options, right? Either you don't think and you just multiply by the other denominator. But the reason I say don't do this part was because in the end, you're going to have to do more factoring and more simplification, right? If you just look at what the other side has, that the other side doesn't, there's less simplification that would have to happen. So maybe we can demonstrate that in the next example. All right. So here we have to multiply by some things, right? Okay, so the easy route, and this is what I was saying earlier, you just look at whatever the other denominator is. 5x minus 4, top and bottom, 5x minus 4. Right hand side, 5x over 5x. All right, this way will work every single time, but it does get complicated because there are a lot more variables than like there's a lot of things to multiply is what I'm saying. So yeah, I'll leave it at that. All right. So is this the lowest thing to multiply both sides by? No. What I'm going to use for the simple fact that I already noticed that each side has a 5, therefore I'm not multiplying each side by 5. I'm not going to use 5. And this will keep the numbers small. That's what I'm saying. Okay, so I'm going to do x on the right, top and bottom, and then x minus 4 on the left, top and bottom. And this is better, in my opinion, only because, again, it's going to keep the figure small, right? Instead of multiplying by a 5 in there. So the denominator is going to be x minus 4. I'll put the 5 out front just to keep things kind of simple. It doesn't matter the order, right? It's multiplication. So x minus 4, 12x, 5, x minus 4x. Okay. Combining these, denominator is going to be 5x minus 4x. So I'm going to leave the denominator factored for the simple fact that some things might cancel here in a bit. X minus 4, x minus 4, minus 12x. Okay. Now, here, it's very tempting to cancel like this. You cannot do that because of the because of the minus. When things are being subtracted and added, you can't cancel things out. Oh, when things are being multiplied, that's different. You 100% can cancel things. So I'm gonna have to expand out the top, meaning we're gonna FOIL this out and then combine it with negative 12, or combine the like terms. So it's going to be x squared minus 4x plus 16 minus 12x. This is going to be negative 8x. Well, it's negative 8x minus 12, so negative 20. So x squared minus 20x plus 16 all over 5x minus 4x. So can the top be factored? That's the question. Two numbers that make 16 that add up to negative 20. 1 and 16, 2 and 8, 3, 4 and 4. Okay, so nothing can make negative 20. So it's not factorable. Yeah, so this can't be factored. So this is pretty much the answer. We're there. So remember, always leave the denominator in the factored form. Okay. These will start to go a little bit quicker, hopefully. All right, multiplying left and right. So I know I'm kind of overlapping on the left, but that's okay. So x plus 4, top and bottom. X plus 6, top and bottom. So again, multiplying by the other denominator. So in the numerator, we're going to get up top. So now, kind of like in one step, the denominator is going to be x plus 6, x plus 4. The numerator, we can combine from left to right. 3 x plus 6 minus 1, which I'm not even going to write, x plus 4. All right. Distributing and then combining like terms in the numerator. 3x plus 18 minus x minus 4. Okay, combining like terms, we have 2x plus 14. Denominator, x plus 6, x plus 4. All right, factoring out a 2 from the numerator will give us x plus 7, x plus 6, x plus 4. All right, nothing more we can do there. Okay. So you check to see if you can simplify. Can't simplify anything. However, this x squared minus 4 on the bottom left is a difference of squares. So this is going to be x plus 2, x minus 2. You got to be able to spot that. So when I multiply the left and the right side, this is going to be x plus 2, top and bottom. And then on the left side, I'm not going to multiply by anything because it already has both the denominators that we need. So this is going to be x plus 4, x plus 2, x minus 2, 15, x plus 2, x plus 2, x minus 2. Combining the numerator. That negative is going to have to distribute to everything. All right, numerator, we got x plus 4 minus 15x minus 30. All right, combining like terms in the numerator. Minus 14x minus 26. I'm going to factor out a negative 2. It's going to be 7x plus 13. 2 times 7 is 14. 2 times 13 is 26. All right. Nice. Number 5. All right, these definitely get progressively harder. So, top left, x squared minus 5, can't do nothing. Bottom left, two numbers that make negative 14 that add up. That add up to 5. It's 2 and 7. So positive 7, negative 2. Okay. Multiplying the left and the right. So x minus 2, top and bottom. And then on the left, x plus 7, x minus 2 is already on the right. So it's nice when that works out that way. All right, so combining this, x minus 2, x plus 7, all under x squared minus 5 minus x plus 3, x minus 2. So here we're definitely going to have to FOIL this out, distribute, and then combine like terms. So this is going to be x squared minus 5 minus this negative right here is going to have to distribute for sure. X squared minus 2x plus 3x minus 6. Okay. Combine the like terms here. So this is going to be just x positive. Right, negative 2 plus 3. So we're going to get x squared minus 5. I'm going to distribute the negative now. So minus x squared minus x plus 6. Okay. Combining like terms. X squareds go away. Negative 5 and a 6 make a 1. So, numerator, negative x plus 1 over x minus 2, x plus 7. All right, number 6. So, simplifying. 2x can't do nothing. X plus 4 can't do nothing. X squared plus 4 still can't do anything. X squared minus 16 is a perfect square. Or a difference of squares, rather. So, x plus 4, x minus 4. Okay. Multiplying the left and the right. So on the left hand side, this is going to be x minus 4, top and bottom. Do we really need those? All right, and the right hand side, we don't need to multiply by anything because the denominator has both terms that we're looking for. So putting it all together, the denominator is going to be x plus 4, x minus 4. In the numerator, x minus 4 times 2x minus, and this negative is going to have to distribute, which I'm going to just distribute it now. I'm going to distribute here. 2x squared minus 8x minus x squared minus 4. All right, combining like terms. This is going to make a positive x squared minus 8x minus 4 over x plus 4, x minus 4. Okay, factor in the top. Two numbers that make negative 4 that add up to 8. 1 and 4, 2 and 2. Nothing. So this is it. Okay, factoring the bottoms, we're going to get so negative 8. Two numbers that make negative 8 that add up to 2. 1 and 8, 2 and 4. So 2 and 4. This will be negative and a positive. All right, positive 32 that add up to negative 12. 8 and 4. So they both are negative. Right, because you look here. Negative 12 is what we want. Okay, let's see. Multiplying both sides. So what does the right term have that the left term does not? And x minus 8. Top and bottom. And looking the other direction, the left side has x plus 2, and the right term does not. So hopefully you can see that. Okay, putting it all together, we're going to have, so in the denominator, x minus 8, x plus 2, x minus 4. In the numerator, x minus 8, x plus 3. Right, here's a minus, so minus, and this is going to have to distribute at some point. X minus 5, x plus 2. Do you have to put the brackets? No. I do that just to remind myself, like that's a personal thing that I do, so I don't forget to distribute. Okay. FOIL, x squared plus 3x minus 8x minus 24 minus x squared plus 2x minus 5x minus 10. Right. All over the thing that's in the bottom. All right. Let's combine like terms and then distribute. So x squared minus 5x minus 24. And here, negative. Okay, so do we want to distribute the negative now? So this is going to be negative 3x, but then you distribute the negative, makes it positive 3x. And then positive 10. Writing the bottom does get annoying for sure. So combining like terms, x squareds cancel. 5x and 3x make negative 2x. Negative 24 and 10 make negative 14. X minus 8. X plus 2. X minus 4. So we can factor out a negative 2, leaving behind an x plus 7. That's as much as we can take out. Okay, we got 3 things. First thing I notice, difference of squares. X minus 5, x plus 5. Okay, so since there's 3 terms, x plus 3, x minus 5, x plus 5, this is going to have to get multiplied by something. Minus x minus 1, x minus 5. All right, this is going to have to get multiplied by something. And then plus all right, this is going to be pretty intense. So we're basically playing a game to make all the denominators match. So everything in the bottom, except for the last thing, has a x minus 5. So x minus 5 is going to go on the far right. Right, everything in the bottom needs x minus 5. Everything in the bottom is going to need an x plus 5. Top and bottom. I have enough room. That's going to be an issue. And then everything in the bottom is going to need an x plus 3. So, look, I can just do it like this. I can just write it in. All right, so cleaning it all up, this is going to be... So, up top we have x plus 3, x plus 3, over the denominator, minus do I want to write it all out? Like I'm literally just rewriting what I have up top. All right, I'm gonna be lazy and not write the denominators. The denominator is gonna be x plus 3, x minus 5, x plus 5. All right, we're gonna have to expand all this out and combine like terms. This is so x squared plus 3x plus 3x plus 9. Minus. That's going to have to distribute, but I'm not going to do that right now. We're going to distribute in the very end. So here's where we have 3 binomials. So this is going to be x squared minus x plus 5x minus 5 times x plus 3. Okay. We're gonna I don't want to distribute it just yet. Let's combine these. So combining like terms, we're going to get x squared plus 4x minus 5 All right, that's going to be times x plus 3. And now I can distribute. Every term in the left gets multiplied by the term in the right. So this is going to be x cubed plus 4x squared minus 5x plus 3x squared plus 12x minus 15. Combining the like terms, x cubed plus 7x squared plus 7x minus 15. Okay. Plus, here we're going to distribute again. So 3 times x squared plus 5x minus 5x minus 25. 5x's are going to cancel. That's nice. Actually, no, they don't. No, they do. Because this one's a positive. And then they cancel. Okay. So this is going to be plus. Now the 3 is going to get distributed. 3x squared minus 75. Okay. This is just the numerator. This is wild. All right. So let's see. What do we have? We can't forget about this negative in the middle that's going to have to distribute. So let's bring everything down. So x squared plus 3x plus 3x is going to be 6x plus 9 minus, so now when I put the minus, that's going to have to distribute, and it's going to change all these signs. Plus 3x squared minus 75. Okay, grouping together all the like terms. So there's only one x cubed. So minus x cubed. Where my x squared's at. Here's 1, 2, 3. So they're all positive. 7, 8, 9, 10, 11. So plus 11x squared. All the x's. 6, 7, and that's it. So 6 minus 7 is -1. So just negative x. And then the constants. 9, positive 15, negative 75. So 15 and 9 make 24. 24 minus 75 is 51, negative 51. And this is all over. What was the denominator? X plus 3, x minus 5, x plus 5. Bro, that's crazy. We did it though. It was like last problem difficulty. We're only on number 8. Hopefully it matches the key. If there's a mistake in here, leave it in the comments and let me know. All right. Okay. Number 9. Idea. We're going to make a common denominator, top and bottom. So check it out. X over X. So common denominator is X. In the bottom, 5, 5. So putting all together, we'll write it kind of how it's supposed to. 15x minus 2 over x all over x plus 20. 5 times 4 is 20 over 5. Okay, compound fraction. Fractions inside of fractions. We keep the top fraction. We change it to multiplication. And we flip the bottom. So this is going to be 5 over x plus 20. All right. When we do this, when you're multiplying two fractions, you could think of it as like one big fraction, basically, and see if we can simplify anything. I don't think we can. So this is going to be 15x minus 2 over x plus 20. Just double checking the math in my head. Yeah, there's nothing we can do. That's it. That's all we can do. It looks like things could cancel, but I'm not seeing it. Okay, numerator. What can we take out? We can take out a 4. If I pull out, okay, so if we pull out a 4 from the bottom right on this side right here, right? I can pull out a 4. So this is really going to be 4, 2x minus 5. Is that true? 8, 20. Okay. So 2x minus 5, that's nice. So that means when we get a common denominator, we just have to multiply the left side by 4, top and bottom. Right, that's what that means. So combining the two fractions, the denominator is going to be 4, 2x minus 5, all under 4 minus 7. So this is 4 minus 7. What's 4 minus 7? Negative 3. And this is all over x, 2x minus 5. So again, we keep the top fraction. We change to multiplication. And then we flip the bottom. So this is going to be 2x minus 5 over x. And this is nice because when you're multiplying two fractions, it's like basically one big fraction. And so we can cancel out the 2x minus 5, 2x minus 5. Let's do a different color. 2x minus 5, 2x minus 5. So in the end, we're going to get negative 3 up top for x in the bottom. Okay. Now, there are probably multiple ways of doing this, right? And I don't know, I'm rationalizing it or working it out the way that my mind processes it, right? The way I was taught, the way that makes sense to me, right? So hopefully you can see what I see. If you see a better way, then that's good too. All right, let's only work the numerator at first. So common denominator, I'm seeing difference of squares, x minus 2, x plus 2. So that means this side x plus 2, x plus 2, top and bottom. So this is going to be x minus 2, x plus 2. Combining the top, we're going to get 3, x plus 2 minus 6. My rookie mistake would be to try to combine the 3 and the 6. You cannot, because there's multiplication that's happening. Can't do it. All right, and this is all over. So now let's work the bottom piece. Okay, so this is nice. This is ideal. All right, this is ideal. X minus 2, top and bottom. X plus 2. Okay. The denominator is going to be x minus 2, x plus 2. The numerator, 3, x minus 2 plus x plus 2. Okay, that's kind of cool, actually. All right, so couple of different ways of thinking about this, right? If you stick to the script, keeping the top, changing the multiplication, flip the bottom, that will work. So x minus 2, x plus 2, 3x minus 2, x. Because when you're adding, you could drop the parentheses because you don't need to keep the parentheses because you don't need to distribute the positive sign. You only distribute the negative sign. So there are a couple ways of thinking about this, right? Here we can see what cancels. X minus 2, x minus 2, x plus 2, x plus 2. All right, check it out. Before we even did that, right before we even did that, when you have a compound fraction and you have a fraction in the numerator, fraction in the denominator, which we do, if you notice right away that both the denominators match, you can cancel out the denominators when you have a compound fraction. Denominator in top matches the denominator in the bottom. Right, so they could just cancel. So had this been me working this out just by myself, I would have canceled right here like this first. And then you see you have a numerator and a denominator, the red part and the blue part, that they're left behind. And that's exactly what we have in the black. So x minus 2, x plus 2 over, let's distribute the 3. This is going to be 3x minus 6 plus x plus 2. So then that's going to be 4x minus 4 so we can factor out a 4 from the denominator. Okay. Yeah, that one's fun for sure. Almost. All right, number 12. work in the denominator, we're going to get, so both denominators already have a common denominator. So this is going to be 5 minus 4 all over m, which is basically 1 over m. That's a 1. So we're going to keep the top, change it to multiplication, flip the bottom. And this is going to be 5m over 4. That one looked complicated. That one's actually pretty nice. I'm sure I didn't miss anything on that one. The denominators match. Yeah, I like that one. That one's good. Okay, so that concludes the adding and subtracting rational. So here's some factoring that is useful. So what is common to both the left and the right term? An x squared. Right, I can take out an x squared. So x squared is going to come out. What about the y's? What's the biggest y? Y to the 4th. So y to the 4th. So what's left behind after we factor out all these things? So when I take out an x squared, there's going to be an x left behind. When I take out a y to the 4th, basically a 1, so I don't need to write a 1. So this is going to be y. So let's see if I factor it back in. X cubed x y4, or x cubed y4, x squared y to the 5th. All right. All right. Hopefully you can follow along on that thought process. Factor completely. So there's a difference of squares for sure. 2 squared, 5 squared. So all of this is really 2/5 y squared. Right, there's a square on everything. The square can pop out. And this is a difference of squares. Right here, look, I'll write it so you can see it. A squared minus b squared. This is really a minus b, a plus b. Question is, what's my a and what's b? So a is going to be x. B is going to be 2/5 y. I can always edit it out. I can edit it out. So a minus b, a plus b. All right, factor in 4 terms. The idea is we're going to factor by grouping. That's what this is called. So you split it, right? It's 4 terms. So you split it down the middle term in front of the sign, whether it's a positive sign, plus sign, or a minus sign, subtraction sign. So you split it down the middle. And then you only look at the left 2 and you factor out the greatest common factor. In this case, it's going to be 6. Left behind is a plus b. The back 2, you factor out the greatest common factor. So they both have an x. So I'm pulling out a positive x. And what's left behind? An a plus b. So the idea is that if these two in the parentheses match, then we're good to go. We can keep factoring things out. If they don't match, no matter how hard you try, it doesn't factor. So here's the idea. When they match, you can simply just write down that part in a parentheses underneath. Because what's really happening, right, if you think of it as two different terms, the term on the left, 6, a plus b, term on the right, x, a plus b, what's common to both of those? The a plus b part. So that's the part that's getting factored out. I'm factoring out an a plus b from both of those. So then what's left behind? A 6 plus x. Right, if I take this whole a plus b and I distribute it, I'm going to get 6 a plus b. Then I'm going to get x a plus b. Right, that's what's happening. But if you don't see that or were never showed that, what you typically taught is the parts that match you write, and then the leftover pieces, 6 plus x, those get written right here. But that's what's happening. You're still factoring out things. Okay, and that's pretty much it. Like, you can't factor it anymore. So that one's fun. All right, we're almost done. Okay, what can I factor out? They both have a c. I'm factoring out a c. C squared minus 27. Man, it's almost like, because I know that 27 is really 3 cubed. And I feel like we could use that right now. But I don't want to. Right? Like, I mean, it's not 3 cubed right here does me nothing. It does me no good. 3 squared would do something, but 3 cubed does nothing. All right, we'll leave it at that. I think that's it. Right, because a square and a cube. It's like a weird joke. A square and a cube are in the same problem together. Okay. Right here, a cubed, b cubed, 64 is really 4 cubed. So we can definitely make something happen. Definitely make something happen here. So this is going to be a cubed plus 4b cubed. The rule, when you have a cubed plus b cubed, I want to say plus minus plus is what I teach, right? Plus minus plus. When this is plus, and then it's going to be a, b, a squared, ab, b squared. And you just got to figure out what your a and b are. The a is a. And then the b is 4b. So a plus b. A plus the b, which is in this case 4b. So then a squared, a 4b, 4b, 4b squared. All right, writing it all out. Just simplifying a little bit. We have a plus 4b Whoa. What happened right here? Where'd that come from? My bad. This is going to be a plus 4b a squared minus 4ab plus, I can square the 4, square the b, 16b squared. Okay, that's it. That was weird. All right, more factor by grouping. Split it down the middle in front of the second symbol. Take out the greatest common factor. In this case, it's 4x minus 3. Hopefully 4x minus 3 shows up. So what's common to the last two, 28x minus 21, a 7. If I take out a plus 7, 7 times 4 is 28. So 4x minus 3 makes negative 21. All right. So they match. I'm going to factor that out. So that's the first part. And what's left behind? X plus 7 factored by grouping. Factor by grouping. Factor completely. So there's two terms. And x plus 5 is common to both. Right? Because we have the first term and then the second term separated by a subtraction sign. So x plus 5. And what's left behind? That's what I'm pulling out of both. So what's left behind? 3 minus 2y. And then there's nothing left we can do. That's it. Okay. Same idea. Two terms. X squared a plus b minus 9 a plus b. So a plus b is common to both. That's what I'm going to factor out first. Leaving behind the outside parts. X squared minus 9. And then x squared minus 9 is the difference of squares. So this is x plus 3, x minus 3. Right, because 9 is really 3 squared. So final answer, a plus b, x plus 3, x minus 3. Bonus. All right, so the symbol's theta. Just treat it like x. Right, this is a basic quadratic. Two numbers that multiply to make negative 40 that add up to 3. Oh, I see. It's a bonus. I'll let you figure it out. Leave your answer in the comment. Catch you in the next video.